So this is on the objective point estimates, margins of error, and confidence intervals. And this is the second video I'm making on this from your Newton Alta homework, the second question from this objective. And it's very, very similar to the first question. So let's take a look. So again, if you're still unfamiliar with this, click on More Instruction, read more on what they have to say about the working with this objective. So a contestant for free movie tickets had for free movie tickets had contestants estimate the number of gumballs in a large bowl. In reviewing the results of a random sample of guesses, a contestant regulator found the mean guess was, X bar equals 136 gumballs, right? So this is a sample mean, X bar, with a margin of error of 13 gumballs. Construct a confidence interval for the mean number of guesses. So remember, a confidence interval is just you're guessing the population mean, right? You're given a sample mean, and using the sample mean as your, that's your point estimate, and a margin of error. Now the margin of error will depend on the confidence level. Right? Usually there's a confidence level, some sort of percentage confidence you have that the true value of the population mean is within these two values, within this range. But you use a point estimate, right, a sample, so from a sample, and a margin of error to get a range of values that you're guessing the population mean is in. Right. So again, back to a piece of paper here. So again, this is going to be a little quicker than my first video. You've already seen this. So a confidence interval. Here we're guessing about the population mean, right? Mu. We're guessing that mu will fall between two values, some lower bound and some upper bound, and they're found in a pretty similar fashion. The upper bound of the confidence interval will be your point estimate, which in this case is, X bar, right, our sample mean, plus the margin of error. Now margin of error is abbreviated ME or MOE or even EBM for error bound of the margin. So plus margin of error. And then the lower bound for our guesses, our confidence interval, is the point estimate, right, which is the value from our sample, minus the margin of error, right? So X bar minus the margin of error. So for this particular problem, our lower bound here, and you might, just see, instead of written this way as an inequality, you might also see it written as an interval. So X bar was 136, 136 gumballs minus, margin of error was 13. And over here, the upper bound for our confidence interval, 136 plus 13. So 136 minus 13, it's 123 gumballs for the lower bound. Then 136 plus 13, there's 149 gumballs. And there's our, confidence interval estimate for the mean number of gumballs. All right. So we're whatever percentage confidence, whatever the confidence level is, we're reasonably confident that the actual average, the actual number of gumballs is somewhere between 123 and 149, right? The actual average guess. So back here, that's where I'm filling in the lower bound, 123, upper bound, 149, and that's it. It's really that simple. Point estimate minus margin of error, point estimate plus margin of error to create a confidence interval. Right. And that's it for this one. Very quick and easy, like the first problem I did. And thanks for watching.